Hello everyone and welcome to the physics lesson. So in this video I'm solving the specimen paper 2. It's for the examination from 2023 according to the new pattern, according to the new topics. Some of the topics have been removed from the previous syllabus and some of the topics have been added. For example, space physics and momentum and stuff like that. And another change is the total marks for the paper. The total marks have now been increased from 75 to 80. So from 2023 onward, from this year, all the physics exams would be of paper 2 would be of 80 marks. Another change is they have changed the value of g, small g, the gravitational field strength or the acceleration of free fall from 10. Previously we used to take it as 10, but now they have made it more precise, that is 9.8. So wherever we have to plug the value of small g, gravitational field strength or acceleration of free fall, we don't use it as 10, we use 9.8 Newton per kilograms or 9.8 Newton per meter square. And lastly, in this paper there won't be two sections, section A and B. There would not be any sectioning. Matter of fact, you'll have to attempt all the questions, so there would be no choice in it. Like previously you used to have, especially in the section B, you had to attempt 2 out of 3 questions, but in this one there would be no choice in any of the questions. The total time duration for the paper is just the same, 1 hour 45 minutes, but the total marks have been increased from 75 to 80. So let's move on to the first question. Figure 1.1 is a speed time graph for a stone as it falls to the ground. On figure 1.1, a letter X mark a letter X to indicate a point where the rock is moving with a constant speed. So on the graph where there is a constant speed, you have to mark a point and label it with the letter X. And for the next one, a letter Y to indicate a point where the rock is decelerating. So this is a speed time graph. And on that speed time graph, where do you have the constant speed? Well, we have the constant speed in this portion. The speed is 40. It's not being changed in this interval. So anywhere on this region, you can draw a point and mark it with the letter Y, with the letter X. It can be over here where I have marked, it can be over here. Just to be on the safe side, do not mark on the edges. Alright, just try to mark in the middle. A letter Y to indicate a point where the rock is decelerating. Now decelerating is basically the point where the speed of, in this case, the speed of the object decreases, because it's moving in a straight line, so speed is just the same as velocity, where the velocity or the speed is decreasing. So first the velocity or speed should be higher, and then it should have been getting lower. And on the graph you have only one point, which is at 11th second, where the speed is being decreased. So I marked it with the letter Y. You can see the dot over here. A common mistake is many of the students would be marking deceleration point over here, because they see that the curve is bending, is kind of a downward curve. The curve appears to be decreasing, so they'll be marking over here. This region, however, does not represent deceleration. It represents decreasing acceleration. So if they ask you to mark a point in the region of decreasing acceleration, then you can mark some place over here. And let's say they ask you to represent with the letter Z. So decreasing acceleration means you are accelerating, your speed is increasing, but the rate of increase of speed is decreasing. Or by the amount, or you can think of it, the amount by which your speed was increasing is now decreasing. For example, So this is the time and this is the speed. So 0, the speed was, let's say, 0, and 1 second the speed was 10, 2 seconds the speed is 15, 3 seconds the speed is 18, 4 seconds the speed is 19. Now you see your speed is actually increasing, but in the first second the speed increased by 10 units, then it increased by 5 units, then it increased by 3 units, and then it increased by 1 unit for the same difference or the same interval of time. So your speed is increasing, but the rate of increase of speed is decreasing. This is called decreasing acceleration. It is independent of deceleration. So because we don't have to mark decreasing acceleration, I'm going to rub it off from here. Moving on to the next part. At time t equals to 0, the acceleration of the stone is equal to the acceleration of the free fall. So at time t equals to 0, you can see from the graph at time t equals to 0, the object was moving with 0 speed, means it was not moving at all. Give the name of the force accelerating the stone at time t equals to 0. At time t equals to 0, the force that would start the object to accelerate is the weight. Only the gravitational force, or you can simply write the weight of the stone. Because since it was not moving, so there would be no air resistance or nothing like that. Just the weight of the object. Then you have the next one. The weight of the stone is 4 Newton. As the stone falls, the force F of the air resistance on the rock changes. State the value of F at t equals to 0. Like I said, at t equals to 0, the object was not moving, and if it is not moving, there would be no air resistance, so F equals 0. And no need to write the unit is already there. Second part, state the value of F at time t equals to 10.0 second. So you see at t equals to 10 second, they're referring to this point over here. It is having uniform speed, and since it's moving in a straight line, it is having uniform velocity. And we can have uniform speed or uniform velocity if the forces are balanced. There was a force of weight which is 4 Newton, and there is now air resistance, and in order for the forces to be balanced, the air resistance should be equal to the weight. So air resistance should also be 4 Newton. So for this one, you can simply write here 4 Newton. And unit is already there, so you can simply write 4.0. Suggest why F changes means the air resistance. All right, F represents air resistance here. They have represented over here. Suggest why F changes between 0 and 10 seconds. So air resistance is being changed due to the change in speed. So as the speed changes, the air resistance changes. And matter of fact, the air resistance at first increases. So as the speed increases, the air resistance also increases. And it increases till probably at this point, and then the air resistance also becomes constant. Part C. Using figure 1.1, determine the acceleration of the rock at t equals to 4.0 seconds. State the unit of your answer. You'll need to draw a tangent to the graph in figure 1.1 and show your working. So basically, they have done you a favor by mentioning that you need to draw a tangent to the graph. Otherwise, you have to realize it by yourself. Whenever you have a curve, you have to find the gradient of the curve by using the method of drawing the tangent. And how do we find acceleration from the speed time graph? We find the acceleration from the speed time graph by drawing the tangent. Now we need to find the acceleration at 0.4 second. So at 4 second, the graph is not a straight line, it is a curve, so we have to draw the tangent. If it were a straight line, we would have simply applied the formula of gradient and we could have found the acceleration, the value of acceleration. So for 4 seconds, first you need to draw a tangent. Alright, I have drawn with this line over here. You can see the red line. I have drawn the tangent. Let's zoom it in a bit. So tangent is a line that should be touching the curve only at the mentioned point. So this red line touches the curve at 4 seconds only. Alright, pretty much. There should not be a dramatic difference. It should appear that it is touching the point, it is touching the curve only at the mentioned point. What do you do afterwards? You choose any 2 points. I have chosen this one from the line, and the other one that I have chosen is this one. And then I can just write down the coordinates of those points because I'll be using them to find the gradient. So the 2 points that I have chosen is 222 and 642. When you're choosing the points, try to choose the points that are easy for the calculation. The point should not be, if it is possible, then ensure that the points are not in the decimal. Just try to keep it on these, just to keep it on the safe side, try to use easy points. And so I had chosen 2 points. I've written over here. The first one was 222 and the second one was 642. Then you write down the formula of the acceleration, which in this case is the gradient of the tangent, and the formula for the gradient is y2 minus y1 over x2 minus x1. So this one is your x1, this is your y1, this is your x2, this is your y2. You plug the values of these points in the formula and you do the calculation on the calculator. You would be coming up with the answer, and the unit of the acceleration in this case would be meter per second square, because the distance was given in meters. You see, the speed was given in meter per second, not in centimeter per second or millimeter per second. So the unit has to be consistent with the graph. So in this case it would be 5 meter per second square. Then we have the next one. The mass of the stone is 408 grams. Determine the force of the air resistance acting on the rock at t equals to 4 seconds. What is the acceleration at this point? We just calculated. So we do have the acceleration at 4 seconds also. We do have the value of A, we do have the value of M. We just hit it on the calculator, we multiply these two, and we get the answer. The common mistake here is many of the students, they won't be converting the mass of the stone from grams into kilograms. Kilograms being the standard unit, so the mass has to be in kilograms. Only then the value of force would be in newtons. If your mass, you use the mass in grams, the value of force can never be in newtons. So you have to first convert 408 grams into kilograms. And how do we do that? 408 divided by 1000. And you get 0.408 kilograms. You multiply it by whatever value of acceleration you had. Hit it on the calculator. You can write your answer to 2 significant figures if you want, or you can write as it is and you get 2 marks for it. Once again, the unit is already there, so no need to write Newton once again. Here we have the next one. Question number 2. Figure 2.1 shows a black car going up a hill on a sunny day. State one way in which car is gaining the thermal energy. Inside the car, as the fuel burns, as the petrol burns, it releases the heat energy in the engine, which is gained by the car. Another way could have been the heat energy or the radiations that the sun radiations or the solar radiations that the car is absorbing, that are being absorbed by the car. One way in which car is losing the thermal energy, the heat of the car is being lost to the surrounding in form of radiation, also in form of some of the heat is being released to the surrounding by convection also, because the air would the hot air would rise up and it would take away some of the heat energy, some of the thermal energy of the car. Then we have the next one, the car accelerates up the hill. In addition to increase in thermal energy, there are other energy transfers taking place. Describe the energy transfers. Chemical potential energy, which is the energy of the fuel, is being consumed. So that decreases as a car consumes the fuel. This energy is converted into gravitational potential energy and kinetic energy, because the car is moving, accelerating, so there would be kinetic energy. Up the hill means it's gaining some height, so there would be potential energy also, gravitational potential energy also. So the chemical potential energy of the car is being converted into gravitational potential energy and kinetic energy of the car. Also, there would be sound energy as well as the car is moving, and there would be thermal energy also, but since the thermal energy they have already mentioned, so you don't need to write thermal energy over here. The energies that are being increased are gravitational potential energy and kinetic energy. These are the main forms of energy. Then we have the next one. The kinetic energy of the car is given as 90 kilojoules. Kilo means 1000. So 90 kilojoules means 90,000 joules. Alright, so you always need to get down with the prefixes first. So 90,000 joules is the kinetic energy. The mass of the car is 8,000. We need to find the speed of the car. It's a very important question for 3 marks. They give you the value of kinetic energy and they ask you to find the speed. So we use the same formula of kinetic energy. Kinetic energy equals to 1/2 times mass times the square of the speed. So basically it's not only the formula of kinetic energy, you should call it's the equation that relates kinetic energy with mass and velocity. So if you're given with 2 things, you can always find the third one. In this case, we are given with mass, we are given with kinetic energy. We can rearrange it to find the value of square of velocity, and then we can take square root of it and we get the value of speed, which would be, you hit it on the calculator, it would be 15. Unit is already there, meter per second. Question number 3. A passenger in the aircraft seals some air inside a plastic bag. Explain how the pressure of the air in the bag, explain how the particles of the air in the bag exert pressure on the inside of the bag. All you have to do is to define pressure in terms of the force and area. So what you write is, when the air particles hit the inside of the walls, they exert force on specific area of the walls, and force per unit area is the pressure. So you get 2 marks for mentioning about the force, for mentioning about the pressure, and for stating that force on a certain area, force per unit area is pressure. Then we have part B, kind of an easy one. When a bag is closed, the pressure is given 80 kilopascal, and then the volume is given 500 cubic centimeter. You need to calculate the volume of the airbag when the pressure is changed from 80 to 1000 kilopascal. Now, first of all, in this one, you don't need to convert or get away with the prefixes because both the values of pressure are given in kilopascal. So even if you do, it won't make any difference because the value of the units for the pressure are being cancelled out anyway. So I can just write 80. First of all, the formula that we have is P1V1 equals to P2V2. The actual formula, the overall formula is P1V1 over T1 equals to P2V2 over T2. But since the temperature is constant, they have not mentioned any change in temperature, so temperature is constant. We can just ignore temperature from here and you'll be left with P1V1 equals to P2V2. And what do you need to find? You need to find the volume of the air, the new volume. So V2 has to be made the subject. Instead of V2, you can write X, or you can just write V2. You hit it on the calculator, you find the value of volume, which is 400 cubic centimeter. And that makes sense because the pressure increased from 80 to 100. Pressure is being increased, so the volume should have been decreased. And the initial volume was 500 and the new volume should have been less than 500. And also, one of the common mistake is many of the students would try to do it by cross multiplication. Cross multiplication works only for the quantities which are directly proportional to each other. If you want to do it by that method, you have to multiply in the line. So not cross multiplication but line multiplication. The quantities written next to each other would be multiplied with each other, and then in the second row the quantities written would be multiplied with each other. Step 1 assumption that you made in your calculation, like I said, the temperature is constant, only then we can use the formula. Otherwise the volume would also depend on the temperature and the answer might be other than 400. So the temperature of the gas is not changed, or the total mass of the gas is not changed. Then we have the next one, the point plotted on the graph in figure 3.2 shows the initial pressure and volume of the air inside the bag. Sketch a line on figure 3.2 to show how the volume of the air changes as the pressure increases. So they have given you this point only, and you need to complete the graph. This one is given already, and that's it. Now the thing is, first of all, the graph of pressure volume is something like this. Why? Because these two are quantities which are inversely proportional to each other, and whenever we have two quantities inversely proportional to each other, the graph is always like this. One of the point is already given, which is 500 from the or you can say 80 from the pressure and 500 from the volume. We have to choose another point from where we have to draw the graph. The thing about pressure and volume is the product is always constant, and this is what the formula says: P1V1 equals to P2V2. That tells you that the product of pressure and volume is constant if the temperature is not being changed. What is the product of pressure and volume over here? It is 80 times 500, which is 40,000. Then you have to choose another point where the product of pressure and volume is 40,000. For example, this one. The value of volume is 400. The value of pressure is 100. What is the product? 4,000. So I marked a point over here. Then I just join these 2 points with a curve. And this is how you draw the graph of pressure and volume. Question number 4. One type of the renewable energy source is shown in 4.1. It is the energy coming from under the surface of the earth from the hot rocks. We call it geothermal energy. So what's the name of this renewable energy? Geothermal energy. Then you have the second part, part B, kind of an easy one. Just getting away with the statement, you're given with the value of mass of the cold water, and you're given with the value of specific heat capacity, and you're given with the change in temperature. You need to calculate the energy that is needed for the water to raise its temperature from 20 to 100. You simply apply the formula, that is E equals energy equals to mc delta T, or you can also write delta theta. Delta theta, delta T, they represent the change in temperature. Energy equals to mass. The mass is 1000 given in the data. C is 4200 given in the data. Delta theta is 100 minus 20. Change in temperature is 80. You hit it on the calculator, you get this answer. You can convert it into two significant figures if you want, or you can just write it down as it is. It's just a better idea, a good idea, that whenever your answer is more than 10,000, you convert it into scientific form. So 3.4 into 10 to the power 8 joules. Unit is already there, no need to write the unit. Explain why more heat energy is transferred. Transfer in this case is released when 1 kilogram of steam cools to 20 degrees Celsius, then when 1 kilogram of hot water cools to 20 degrees Celsius. Now for this one, you have to think about it. When you have steam, you have to cool the steam to, let's say, water at 20 degrees Celsius. Then there are a couple of things that have to take place. First of all, your steam, which is at 100 degrees Celsius, would be converted into liquid water. Or the steam may not even be at 100 degrees Celsius. It might be even at a higher temperature. Yeah, it might be, let's say, at a temperature of 150. So first, your steam has to be converted into liquid water at a temperature of 100 degrees Celsius. And then the liquid water has to be converted, has to be cooled down to a temperature of 20 degrees Celsius. So part of the heat energy would be released in this process, which is the latent heat. Because first, your steam cools down to 100 degrees Celsius, you get the heat energy released from due to the temperature change. Then when it reaches a temperature of 100 degrees Celsius, even for the simplicity, if we say the steam was at 100 degrees Celsius, then from gas it has to be first converted into liquid. So there would be heat energy released due to phase change that we call latent heat. And then there would be heat energy released due to temperature change, once its temperature decreases from 100 to 20 degrees Celsius. So how do you write down this one as the answer? Steam is being changed from gas to liquid. Hence the phase change also occurs, the energy of which is given out as the latent heat. So during that phase change, even if your steam is at 100 degrees Celsius, in order to convert the steam into liquid water, part of heat energy has to be released into the atmosphere, to the surrounding, in form of the latent heat, and only then the potential energy of your steam would be decreased to convert it into liquid water. So this is the reason why more of the heat energy would be released when the steam is being cooled compared to when hot water is being cooled. When your hot water is being cooled, all you have is the energy due to temperature change. When the steam is being cooled to 20 degrees Celsius, you have the heat energy due to temperature change plus the heat energy being released due to phase change. Alright, moving on to the next one, question number 5. Figure 5.1 shows the light in air incident on the side of a rectangular block at an angle 60 degree. The refractive index of the glass is 1.6. The light travels in the glass and an incident on the side xy at P. Underline all the terms that describe the wave of light. The light wave is from the electromagnetic spectrum, part of the electromagnetic spectrum. So electromagnetic spectrum, check. It is a transverse wave. All the electromagnetic waves are transverse waves, so the last one, check. At the point P where the light enters the glass, find the angle of refraction. Whenever a ray of light enters from less dense medium to a dense medium, we use the formula as it is, n equals to sine I over sine r. This can be used to find refractive index. This can be used to find angle of incidence. This can be used to find angle of refraction. Matter of fact, out of three things, if two things are given, you can always find the third one. So angle of incidence was 60. The value of n, refractive index, is 1.6. You divide these two, then you take sine inverse, because you need to find the value of r, not sine r, so you need to get rid of sine. Calculate the critical angle C for the light traveling in the glass block. For the critical angle, we have the formula n equals to 1 over sine C. This formula we get from the same expression, n equals to sine I over sine r. First we reverse it, because for the critical angle it has to be dense medium towards less dense medium. Then it will be n equals to sine r over sine I. And then for the critical angle, the angle of refraction has to be 90, so sine 90 over sine I. Then the value of sine 90 is 1, and the angle of incidence in that case would be called critical angle. So this is how we get formula. You simply plug the values of the given data and you get the value of C as 39. At P, the angle theta between the ray and the normal is given by theta equals to 90 minus r. Stay and explain what happens to the light when it is incident on the side xy. So this angle, they have shown this angle over here is 90 minus r. So you see this angle is r and that angle would also be r. Alternate angles, bit of mathematics going on here. And then you have the normal line. The angle between the surface and the normal is 90. So the lower one is r, the upper one would be 90 minus r. And what was the value of r we calculated in the very first part? It was 33. So 90 minus 33, you get something like 57. The critical angle was, angle of incidence is 57. The critical angle was 39. How much was that? Yeah, 39. Your angle of incidence is greater than the critical angle, and the light is coming out from the glass, is entering from the glass to here, and the angle of incidence is greater than the critical angle. These are the two conditions which are being satisfied, and if these two conditions are being satisfied, we get the process that we know as total internal reflection. So the ray of light would be reflected back into the glass. It won't be coming out of the glass. Alright, moving on to the next one. A 4.5 volt battery is connected in a circuit with an ammeter, a light dependent resistor LDR, and 1800 ohm fixed resistor. Figure 6.1 is the circuit diagram. These two resistors are connected in parallel. As we can see, both ends are joined with each other. They are not in series because they are not connected in a straight line. The LDR causes, the light incident on the LDR causes its resistance to be 9000. The resistance of the second one is also given 9000. For the first one it is 1800. You need to find in the first part total resistance of the circuit. This is a standard formula for when the resistors are connected in parallel. So it'll be something like 1 over R total equals to 1 over 1800 plus 1 over 9000, and you simplify it on the calculator, and then you cross multiply to find value of RT, or for two resistors you have a shortcut, simpler formula. product of the two resistors divided by the sum of the two resistors. The first one is 1800, the second one is 9000. So 1800 times 9000 divided by 1800 plus 9000. Hitting on the calculator, you'll be getting your answer 1500. Unit is already there, ohm. In the next part, you need to find reading on the ammeter. Ammeter at this position is measuring the total current of the circuit. And the formula of current according to the Ohm's law, if you rearrange it, I equals to V over R. Since the ammeter is measuring the total current, you need to plug the value of total voltage and you need to plug the value of total resistance. And both the values are already given. You simply plug in the formula, hit it on the calculator, 4.5 divided by 1500. You write down the answer 0.0030. I have written in two significant figures. A very bright lamp is switched on and the intensity of the light on the LDR increases. State and explain what happens to the current in the LDR. So a bright lamp is switched on and intensity of light on the LDR increases. As the intensity of light on the LDR increases, its resistance decreases. This is what we study in the working of the LDR. And if its resistance is being decreased, the current in the LDR would increase. Then we have the next one, state and explain what happens to the current in the 1800 ohm resistor. In the 1800 ohm resistor, for the first one, you see if you're trying to find the current in this one, the formula would be V over R. The potential difference across it divided by its resistance. Since the potential difference across the first one would remain same, 4.5. Because we're using the same battery. And in parallel, the voltage across the components is just the same as the EMF of the battery if there is no other component in the middle. I mean, there's no other resistor over here. So that whatever the EMF of the battery is, that would be the voltage across all of the components connected in parallel. So the voltage remains 4.5. The resistance remains 1800. The ratio of these two would remain same, so the current would also remain same. Even if you calculate it mathematically, it would remain same. So this is how you can answer for this one. Neither resistance nor the EMF of the battery or nor the potential difference across the 1800 ohm resistor changed. So the value of current in the resistor would also remain same.